Welcome to Tatomasi. So another video on electrostatics. So in this video, we are discussing a previously asked JEE question. So this question is asked in JEE Advanced 2014. So it's a question asked in JEE Advanced 2014. So first of all, let me read the question first. The question is, assume that an electric field E is equal to 30 x square I exists in a space. So assume that an electric field E is equal to 30 x square I. That is very important. I means it's along the x direction. So 30 x square I exists in space along the positive x direction, 30 x square I. Then the potential difference VA minus V0, where V0 is the potential at origin. So V0 is the potential at origin, O. O is the origin. At that point, the potential is V0, and VA is the potential at point A, where at x is equal to 2. A is at a point 2 units in the x-axis. So A is a point at a distance 2 units from the origin. Then they are asking the potential difference VA minus V0. They are asking what the options I will read. So what is the potential difference VA minus V0? I will repeat the question once again. It's easy only. Assume that an electric field E is equal to 30 x square I exists in space. 30 x square I, that means the electric field is in the positive x direction. Then the potential difference VA minus V0, where V0 is the potential at the origin, V0 is the potential at the origin, and VA the potential at x is equal to 2 meter is. VA is the potential at x is equal to 2 meters. So this point x is, this is 0 and this is 2. This point is 2 units. This is 0, 0 origin. So what is the potential difference VA minus V0? So this is the question. So some of the concepts we are using to solve this question, I will beginning itself I will tell you, and after that we will discuss this question. Okay. So before that you understood the question. They have given the electric field, that is 30 x square I. So x is a variable in the x direction. So the electric field is in terms of I. So it is in the x direction. That we understood. Then they are asking the potential difference VA minus V0, where V0 is the potential at the origin and VA is the potential at a distance 2 meter from the origin. Okay. Now I will come to the point. The concepts we are using here. The first point is potential as the negative line integral of electric field. Here I haven't put the negative sign, that I will explain you later. The potential difference or potential is the negative line integral of electric field. It's very important. 3 aspects, 3 points I have already discussed with you. The first point is surface integral of electric field, electric flux. Negative line integral of electric field, electric potential. Third point, the negative gradient of potential, electric field, is electric field. So these 3 points I already discussed. Now we are using the second point here to solve the question. Potential difference is the negative line integral of electric field, because the charge is moving, the potential difference along the x direction. So, and the electric field is given in the form of a variable, it is 30x square. Now we have to integrate, then only we can find it, because electric field is not a in a number, it is given in terms of a variable. Okay, so we have to do the integration process. If it is a finite quantity, if it is 20 or 30, you can directly go for the normal process, like the normal formulas you can use. For potential, you have the formulas like W by Q or 1 by 4 pi epsilon 0 Q by R. These two are the fundamental formulas. So when you will use these formulas, when you have the potential or the inputs, electric field or charge, they are given in as finite numbers. If it is electric field, they are giving it as 20 or 30. In that way, you can go with the process of normal formulas. But when it is given in terms of a variable, we have to integrate or differentiate that, sure. So that's why we have gone with the formula potential difference is equal to negative line integral of electric field. Clear? That's the first point. The second point is why I didn't put the negative sign here. From first year itself, you learned it in heat as well, in first law of thermodynamics as well. Work done by a system is taken as positive, work done on the system is taken as negative. So when you are moving a charge, if you have a positive charge here, so when you are moving a unit positive test charge against this, then at that time only the potential is negative. So here the field is like this, and you are moving the unit positive test charge against the field, then it is negative or against the repulsive force here, or you can tell it is against the field. This is the direction of electric field. Then the potential is negative line integral. But here, since it is along the positive direction, I have already explained to you, the intensity of electric field is in the positive x direction. So that means the electric field is this. Now we need to calculate the potential difference between VA and V0. So I have to move the charge, unit positive test charge also in this direction only. Same direction. You got it? Here the electric field is in the positive direction because from the question it is understood. To find the potential difference between VA and V0, VA is the final, V0 is the initial. We have to move from the charge from here to this, from the moving the test charge from V0 to VA. So at that time, so the potential, the potential difference. So we are moving the charge in the same direction of the electric field. Here, if you see, we are moving the charge. Here, we are moving the charge against the field. So you could see it. So at that time, it is negative line integral. If you see here, the electric field is in the positive x direction. To find the potential difference from VA to V0, we will move the charge from initial to final. That's what. So that is the potential difference. The charge is moving from initial to final. So that is the potential difference VA minus V0. If we are moving the charge in this direction, it is V0 minus VA. Okay. So till now you are clear. So here both are in the same direction. So that this is plus, not negative line integral. So I didn't put the negative line integral because we are not doing work here. The work is here. We are doing the work. System is not doing the. We are doing the work on the system. At that time negative. Here work is done by the system. At that time it is positive. In that way also you can explain. From the first year physics, the heat and thermodynamics, first law of thermodynamics. You learned it. Work done by the system is taken as positive. Work done on the system is taken as negative. It's very simple only. If you are doing work, means it is negative. Here when you do the work against the field. Here it's same as that of the field, no need to do work. So at that time it is possible. Now we will apply the limits. Sorry. So E dx. So E, now it is simple, very simple. E you substituted as 30x square. No need to consider the I and all. It is very important to explain this concept, whether it is, because here two answers, negative and positive. Here it is to confuse you. So this from the choices, if they have given only positive answers, these concepts no need to think. So this negative and positive signs, numbers, it has lot of significance. This is an advanced JEE advanced 2014 question. So you have to understand these concepts. Then only you can do it. Again I am repeating, when work is done against the repulsive force, that is negative. That is, work is done by you, not by the system. That is when you do the work against the field. Here both not against the field, same direction as that of the field. At that time it is positive. So I substituted 30x square, the simple formula, line integral of electric field, then 30x square, integral of 0 to 2 30x square dx. 30 I have taken outside the integral, you know the process. Now I can tell you the integral of x raised to n, the fundamental formula. I am telling you, integral of x raised to n dx is x raised to n plus 1 by n plus 1. d by dx of x raised to n, derivative of x raised to n is n x raised to n minus 1. Two fundamental formulas. Integral of x raised to n dx is equal to x raised to n plus 1 by n plus 1. That only we are using. It is integral of 30 common x square dx. See, x cube by 3. You know it. Then we will apply the limits 0 to 2. Now we will apply the upper limit, that is instead of x2, 2 cube, that is 8 minus, so 3 also I have taken outside. So this 3 also I have 30 by 3. So 2 cube minus, then the lower limit it is 0, that is 8 minus 0. Okay. So 30 by 3, it is 10. 10 into 8, it is 80. So the answer is D. Sorry, not D, it is plus 80, C. You understood? So it is not negative minus 80. It is plus 80 because from this I is having lot of significance. From that I, we understood the electric field is in the positive x direction, and we are moving the charge also along the field, not against the field, in the same direction as of the field. So it is positive. When you are doing the when the motion is against the field, you have to do the work and it is negative. That is negative line integral. Here it is positive. So you understood this question. So again I am telling, these type of questions are very simple if you know the concepts. So when you learn potential or potential difference, just you by heart some formulas, W by Q or 1 by 4 pi epsilon 0 Q by R, you cannot answer these questions. So you have to understand how the charge is moving when it is negative. So why it is negative line integral, and when it is negative line integral. So when it is positive line integral. So when the negative line integral comes when work is done by you, that is the motion of the charge is against the field. When it is positive, when is work done by the system, that is the direction of the charge is along the direction of the field. The motion of the charge is along the direction, both are in the same direction, work is positive. So at that time we will use, that is the case here. So this type of questions are very easy if you know the concepts. These are all not concept things. So the JEE questions, to attempt these exams, to crack these exams, it's very easy. So you need to show the focus and the dedication, and you have to work. Then it's very easy. So thanks for watching, and please subscribe so you can use the Tatumasi logo at the end of this video. Please subscribe. Thanks a lot.